Okay, so what I'm going to ask for you guys to do today is a little bit different. So what I'm going to show you guys is an example, and I'm going to ask that you pause your video, try to work out the example on your own, and then once you feel like you have an answer, go ahead and resume watching the video, and it will walk you through the answer itself. So first off, this example, you have a pizzeria that sells two different types of pizza. One is rectangular, and one is a large round pizza. Notice it does give you the dimensions. What if both pizzas are of the same thickness? Which option gives you the most money for, excuse me, the most pizza for the money? So here's a couple quick things to just make note of. First off, they are going to be the same price. So the main thing that we're looking for then is area. So we have a rectangular pizza that is 18 by 24, and then we also have a round pizza that is 24 inches in diameter. And so all we would really need to do is calculate the area of those two things. So we have 18 inches by 24 inches, and when we look at the fact that that's a rectangle, you're just doing length times width, which will give us 432 square inches. The other one, since it is a circle, we're going to have to use the formula pi r squared to figure out the area of that circle. Now, remember this is a 24-inch diameter, which means that your radius is going to be 12. And so when we plug that in, that's going to give us an area of 452 square inches. So again, since our price is the same, we don't have to worry about figuring out like price per square inch or anything of that matter. Basically, all we're looking at is which one gives us more pizza. And in this case, it's the circle one that gives us more pizza. When we look at this second example for today, again, what I would ask for you to do is go ahead and just pause your video and see if you can figure out the answer for this. Now, when you look at this, one of the things that I would recommend is look at your table, and the first thing that you have to do is figuring out what graphical model fits the data. Now, I'm a very visual person, so even though this isn't going to be the most accurate graph in the world, what I'm going to do is I'm going to sketch a graph just so I can kind of see what's happening. All right, so I've got 0, 0, 1, and then 0.75, and then 2 and 3, and I'm just eyeballing this. There's no perfect way to do this. So again, that's at 3, so there's 5, there's 10, there's 15, and I'm just going to kind of label these 4, 12, 5, and then all of a sudden you see that this grows super, super quickly. Now, what we can do is we can kind of think about the models that you guys already know and that you can use quickly. One of them is the linear model, which obviously this is not the case because it grows super quickly. And if you notice the difference between each one of these, as you look at this, it's not a consistent difference. So it's not a linear model. But one of the other ones that we can see is the quadratic model. Excuse me, I couldn't think of that word for a second. The quadratic model. So you are looking to see, does this fit y equals and then ax squared? The quadratic being the x squared, the a being a constant that we would have to make sure that we look at and try to figure out. So what I'm going to do is I'm going to test this to see if it works. Now I understand the quadratic model. Technically you would have this other half, but we don't have anything in negative time, so we can't really figure out that other half. Okay, so what we would do is we would go ahead and plug in a point. And for me, the point that makes the most sense to be able to figure out A is the very first point, the point where I can plug in 1 for my x. And so I'm going to have this. Once I solve for A, I'm going to have 0.75 for A. What I would recommend then is I'm going to test to see if that's going to work for a different point. So if I plug in 0.75 for A, and I'm going to plug in a different point to see if this works. You can pick any point that you want. So I'm going to use this point. And again, you can pick anything. And let's see if that's going to work. So I'm going to do 0.75 times 5 to the second power. And when I type that in my calculator, I do end up getting 18.75. And so since that is what I want to get, this equation is going to be your equation. Now the only other thing that I would recommend is because we don't have x and y in our table, but instead we have time and distance, is possibly going ahead and plugging in those two variables instead of x and y. Is this a big deal? No. But is it something to just kind of get in the good habit of if they give us specific data points? Sure. Okay, so this would be the equation for this specific table. So again, I use the picture to kind of help me see what's going on, but then I would go ahead and pick one of those models and, excuse me, find our constant and then make sure that we check it using another point. Thanks.